one would think that parabolas would be the easiest because we have done parabolas before, right? You've seen parabolas all the way back to Math 1. If you have your computer open, you can go ahead and close it. We do not need it right now. However, I don't believe you guys have seen these parabolas that open sideways yet. Have you? That doesn't look. Yeah. So these are a little tricky, and their equations are a little different than the other conic sections. So even though we have seen them before, they're a little bit trickier than the others. I wouldn't call them terribly difficult, in my opinion, but a little tricky. So parabolas we can look at in several different forms. Often we just see them in expanded form, which is our ax squared plus bx plus c. This is what we need if we want to do like quadratic formula or something with these. Another form we see them in often is factored form. There's a lot of times we might want to factor a quadratic for something, but the one that we're really going to be focused on for this unit is going to be vertex form. Okay, and vertex form is y equals a times x minus h squared plus k. And this is going to allow us to find that vertex. Really, you can kind of think of this as just whenever we learned about those shifts up, down, left, right. This gets it in that form where we can tell it's been shifted up 3 to the left 2, reflected over the x-axis, that sort of thing. So that's what we'll be focusing on today. The tricky part here is going to be whenever we have these sideways parabolas. Okay, if we switch where the x and y's are at, so basically we have an x equals equation and our y is the one that is squared, it is going to be a parabola shape, but it's going to be turned on its side. Okay, so that's going to be a little bit tricky. So in standard form, I should probably write here, vertex form is going to be our standard form whenever you see it referred to as standard form here. I prefer the phrase vertex form because I would, tend to want to call y equals ax squared plus bx plus c standard form for this, but I do not believe that is correct. But if you see that you're supposed to put something in standard form in this unit, you need to put it in vertex form here. So if the parabola opens upwards or downwards, okay, our vertex form is going to be y equals a times x minus h squared plus k. And so you have right here p equals 1 over 4a. This is your focal length for a parabola. Okay, I will give this to you just like for the ellipses, although the other day on the quiz I don't think I gave that to you. I said I was going to and I never did, but nobody asked for it. I don't think it caused a major issue. But I will give you this formula as well for the test, so that will be given to you. For our vertex, we will just have the opposite of h, but the k is going to be the same sign, right? If you think about shifting quadratics, if we move something left or right, it goes opposite direction, so that is here, but this number out here that moves it up or down is the same direction, so we don't change the sign of this k. To find the focus of a parabola, you are going to do hk plus p, that focal length. Your axis of symmetry is going to be x equals h, and then a parabola has a line called a directrix. And that is y equals k minus p. We'll talk a little bit more about what a directrix is here in a minute. But these are just the formulas you have here. You can notice everything sort of switches here. whenever it's solved for x. So over here, for the focal length, we add and subtract to the x instead of the y. All of these variables right here switch, and we'll kind of walk through this a little bit in a moment. So the definition of a parabola is the set of points equidistant from a point and a line. That point is called the focus, and the line is called the directrix. So I have, hopefully here, this Desmos graph will come up. I didn't link it. That I made earlier. So I just want y'all to appreciate what I did here. That's some pretty extensive math right there. I did to get this graph to show up. So you should appreciate that. So I have a parabola here. This red dot right here is my focus. This blue line is the directrix. Notice that they are the same distance from that vertex right there. So this is up one, this is down one, right? And so the definition of a parabola is all the points that are the same distance from that point and that line. So you can see as I move my purple point here, this red dotted line and this red dotted line are the same length, right? So here at this point is the same distance from the focus and the directrix at the same time. So this is our definition for a parabola here. If I want to change my equation of my parabola here, like if I get rid of that 1/4, get rid of that. Oh gosh, never mind. Don't get rid of the 1/4. I don't have this programmed as well as I had thought. If I had programmed this better, then I would make it where we could see this for anything that I did not. But I could have different parabolas that would have the same effect here. I need to make that where it'll work for anything, but it took a little doing to get it to work just for this one. So this is what it means when it says the same distance from a point and a line, right? So knowing the focus and the directrix can help you in a situation where you need to come up with a specific parabola for something. So you won't necessarily be asked to repeat that definition for anything. I just wanted you to see. We will have to find the focus and the directrix, so I wanted you to see what those are as it relates to that definition. Okay. This first one that we have here is already put into vertex form for us. And we are asked to find the vertex, the focus, the directrix, and an axis of symmetry for this particular equation. So, whenever we have an x equals equation, that means that my parabola is going to open to the left or to the right. Okay. The a value right here is 2, and that is a positive number. Okay. So if I have a positive number right here, then my graph is going to open in the positive direction, which when we're talking about left and right is going to be right. So what I'm dealing with here is a parabola that's going to open to the right. Okay, so we need to find the coordinates of that vertex first. The vertex is kind of like, it's similar to the center for the circle, ellipses, and hyperbolas. It's where you figure out everything else from. So you got to find that vertex first. So, does anybody want to take a shot on determining the equation, or not, the coordinates of that vertex?
Wouldn't it be like, wouldn't it have to do with the something that's inside the parentheses?
Mm-hmm.
Plus 4, so it would be like, it would be right before
You would be correct if this was a y equals equation. Okay? So it would be right 4 and up 3 if this was an x and this was a y. But this is where this is confusing because this one's backwards, so we have switched the x and y's. So this y right here is going to cause something to happen in the y direction, right, up or down. And so since it's in parentheses, it's the opposite direction. So your y coordinate is going to be positive 4. And then your x coordinate is also positive 3. You don't change the sign for this one because it's not inside of the parentheses. It's really easy to get that backwards. And that is your vertex, yes. So this is vertex. It's 3, 4. Okay, so to find the focus in the directrix, you have to use that formula that was on one of the slides before, P equals 1 over 4A, which for this problem, the A is 2. That's our A. So we're going to have 1 over 4 times 2, which is going to be 1/8. Okay, so what that means is to get to our focus over here inside of the parabola, we need to go to the right 1/8, and then to get to the directrix, which is going to be this vertical line over here, we would go to the left 1/8. And those should look like they're the same distance away. Haven't drawn it very well there. Okay, so for our focus here, I'm moving to the left or right. So which coordinate is going to change? The x coordinate, right? So this is going to be, I really don't like mixed numbers. Let's see, 1/8, is that 0.125? I think it is. 1/8 is 0.125. So let's just do a decimal. We're going to do 3.125 for our x coordinate, and then 4 is our y coordinate. The y coordinate does not change. Okay, so that is our focus. For this line right here, this is the directrix. Okay, for our directrix, that is a vertical line. The vertical line, what does its equation look like? Is it x equals a number or y equals a number? X equals a number. So x equals whatever this x coordinate is here, right? So my vertex was at 3. To get to the directrix, I had to go to the left 1/8. 2 and 7/8, yes, which we're going to do 2.875. Just, I like to avoid mixed numbers just because they are a little tricky. It's just really easy for 3 and 1/8 to look like 31 over 8. Or it's just, and it's really difficult to like type 3 and 1/8 in to do anything with it in the calculator. So I would generally encourage you to either go decimals or you could go improper fractions. The textbook page that you do, it probably does improper fractions. I don't care which one you do though. If I ask you for focus or directrix, probably. If I ask you for the vertex, probably not. It doesn't necessarily have to be on the calculator active if I ask you for the vertex, but if I give you focus or directrix, it'll probably be on calculator active. And let's see, what else? It wanted also our axis of symmetry. So the axis of symmetry would be the horizontal line. So axis of symmetry. That is horizontal. Horizontal is y equals. What is our y coordinate there? 4.
So if it's an x equals graph, we can just take what's inside the parentheses, figure axis of symmetry. Like set it equal to 0 and add your 4.
Yes. Yeah.
Does it work the same way with a y equals graph?
Yeah, it'll be backwards. It'll be the x equals, yeah. Okay. All right. Okay, now this one, I need to write it in vertex form, and then I've got to find the vertex, focus, directrix, and axis of symmetry. So this is similar to circles, ellipses, and hyperbolas, but it's going to have a few small differences, okay? Well, the biggest difference is we only have one variable that is squared, right? So if your x is squared, then you're going to have one that opens up or down. If your y is squared, you'll have one that opens left or right. In this particular case, we're going to have one that opens up or down. Is it going to open up or down? It is up. How do you know? That positive 2 right there, right? So your x squared term is positive, so you know it's going to open upwards. So we're going to have y equals. We're going to do this similar to the way that we did ellipses. We're going to factor out a 2, but only out of the first 2 terms. Okay? So it's going to look like this. X squared minus 4x, and I'm going to go ahead and put a plus blank here. I'm going to leave this 5 right here. Okay? And so it is okay. You could, if we wanted, we could put a minus or a plus blank here on the other side. But because we want this to be solved for y, because we don't want anything else over here with the y, what I'm going to do instead is I'm going to put out here a minus blank. Because definitely if I have an equation, I can add something to both sides of the equation and it's still the same, right? But if I add something to one side and then subtract that same number from that side, those also cancel out, and what I'm dealing with is still the same. So it's a little bit easier to deal with if you do it this way, although it is possible just to add the plus number over here, and then you're just going to have to move it back over at the end. So, excuse me. So we're going to get y equals, we're going to complete the square here. So it's going to be x minus 2 squared. We'll put a plus 4 right here. What number will I put in my blank over here? 8. Make sure you remember to multiply it by that 2. You guys did. And so 5 minus 8 is 3. Okay, so we are dealing with a parabola that opens upward. And here, Miles, what would our vertex be for this one?
2, -3.
Perfect. 2, -3. This parabola has been moved to the right 2, down 3, so its vertex is going to be at 2, -3. I think it's easier to think about whenever it's y equals because you don't have to do things backwards. So, in order to find our focus, which is here, and our directrix, which is here, we have to have that focal length, which is P equals 1 over 4A. What is our A here? 2. So it ends up being the same as the last problem. I should probably change it so we're not getting the same numbers again, but I'm also use 0.125 for that. So we got 1/8. Now this time for our focus, we're starting at our vertex and we're going up 0.125. So which coordinate needs to change? Y. So it's going to be 2, and then negative 3 plus 0.125 is going to be negative 2.875. There for our focus. We're adding, but because it's negative, it looks like it. Our directrix is going to be that same distance away from that vertex. So it is a horizontal line. Horizontal line is y equals a number. So we're going to take our vertex, our y coordinate of our vertex, which is negative 3. We have to go down 0.125. So we'll get negative 3.125. And then the last thing that we need is our axis of symmetry here. So axis of symmetry, that is a vertical line. It's x equals, our x coordinate of our vertex is 2. So it's going to be x equals 2. Okay, questions? What time do we get out here? All right. Let me look at these. I might change this one. I want to make sure. I'm going to flip ahead and see.
This is a 2-hour class.
Kind of, because our first 30 minutes was OP advisory. So, kind of, yeah. Alright. I'm going to do this for this problem because I don't think I've done it well. It won't hurt for us to do it twice here. So I'm going to put an 8 right here in front of that x. So make it 8x equals y squared minus 12y plus 4. Just because I want something to happen here that is going to happen on the homework, that it will kind of happen on the next problem also, but it probably won't hurt us to see it twice because it's always one that we have a little bit of trouble with. So there's no like mathematical reason other than I just want it to be there for this problem. So if I'm trying to complete the square here, at the end I want this equation to be x equals, right? I do not want that 8 to be there. But if I get rid of the 8 right now, there's going to be a lot of fractions I got to complete the square with, right? So what I'm going to do is I'm going to leave the 8 here and I'm going to deal with it later. I'm going to complete the square first. So I'm going to have y squared minus 12y plus blank plus 4 minus blank. So I'm going to leave that 8 there and I'm going to deal with it later. So if I complete the square here, I'm going to have y minus 6 squared, and 6 squared is 36. So I'm going to need to subtract 36 here, and I will get minus 32. Are we okay here? We can divide the 8. What's it going to look like if I divide the 8? Okay, I'm dividing this by 8 and this by 8. But I really don't want a fraction when I'm having to deal with, not this type of fraction anyway, when I'm having to deal with vertex form, right?
Do it like a fraction and a fraction.
but there is like a 1 right here, right? So I can write it this way: 1/8 y minus 6 squared minus 4, which is going to make my a value 1/8 here. If I have it everything over 8, it makes it difficult to find that a value. Okay, good. So now we have it in vertex form. Is this one going to open up, down, left, right? Which one's it going to be? Okay, left or right? Since my a is positive, is it going to be left or right? Right. Okay, so this is going to be a parabola that opens to the right. And let's see. Who can tell me the vertex? Very good. -4, 6. Remember that 6 right there is with the y, so it's your y coordinates. It's really easy to get those backwards just because we're so used to the x being there. Okay, so for our focal length, that p value, it is 1/4a, so it's 1/4 times 1/8. 4 times 1/8 is 4/8, which is 1/2. What is that going to be? 1 divided by 1/2 is 2. Right? Dividing fractions, easy as pie. Flip the second and multiply, you'll get 2. I actually like it when there's fractions here because it makes your focal length the whole number a lot of times, and then it makes it easier to find the other parts. So our focus here is going to be 2 to the right. So if I've got -4, 6, the focus is going to be at -2, 6. We'll add 2 to the x-coordinate. The directrix over here that is a vertical line, so it's going to be x equals, it is 2 units to the left, so we're going to have -6. And then our last thing that we've got to find is our axis of symmetry. It is a horizontal line, which is y equals, and our y coordinate there is +6. So it depends on whether or not it is vertical or horizontal, whether it will be x or y that you're dealing with. So like on the last problem here, our directrix is always outside of the parabola. So it was horizontal on this one. So it was a y equals equation. So we took the y coordinates of our vertex, which was -3, and we had to go down p from that. On this one, our directrix is vertical because it has to be on the outside of the parabola, running sort of not parallel, but you know it's never going to touch there. So our vertex, the x coordinate was -4, but we had to go 2 units to the left here because that focal length will be the distance from the vertex to that line. And so that x coordinate was -4. We subtracted 2 from it, and that gave us -6. Because it's to the left. Yeah. If it had been on the right, if it had opened the other way, then we would have added 2 for that. So you can deal with these like strictly from formulas, but I usually don't, because all you gotta do is assign. I usually draw a picture of it like I'm doing here, a rough graph of it, so that can help me see. Oh, we're going to the right, we add. We're going to the left, we subtract. I think that gives you a better understanding of what's happening there. Okay, questions? All right. All right, so for the next one, we got y squared equals negative 4x minus times x minus 3. We're supposed to put it in vertex form, find focus, director, x-axis, symmetry. It kind of looks like it's in vertex form. But the y is squared, so it's not in vertex form at all, is it? Because this equation right here needs to be solved for x, not for y. So for this one, I've got y squared equals, I would probably, you can deal with this a couple ways. What would you guys do with that 4, negative 4? Would you distribute? Yeah, you can distribute or divide. Either one. There. I feel like probably more of you would distribute. Some will do that. I'll show you how to do it the other way. You get the same thing. So then I would have y squared minus 12 equals negative 4x. Because I would move it to the other side. And then I would divide everything by negative 4. And there's a 1 right there, so I'd have negative 1/4 y squared plus 3 equals x. Okay, so that's one way. You could have also over here, I'm just going to show you the other way just so you see it as an option. It might be a little bit easier actually. If you divide by negative 4 first, you get negative 1/4 y squared equals x minus 3. And then you just add the 3 there, so you got negative 1/4 y squared plus 3 equals x. So that's another way you could do it. Either's fine. Is this in vertex form? It doesn't look like it. Can we complete the square? We don't have a plain y term, right? This is actually already in vertex form. It does not look like it's in vertex form, but because I don't have, if I had like a 3y here, then I could complete the square, right? But I would have to have a term that had just a single y with it in order to complete the square. So what we're really looking at here is it's like this. It's like we got negative 1/4. It's like we got y minus 0 squared plus 3 is what we're dealing with. Since there's only that y squared term, it is actually in vertex form. It's just sort of in disguise. It doesn't look very vertex formy there. All right, so this is an x equals. That means it's got to open left or right. Which one is this one going to open? Left. We haven't seen one of those yet. And I'm doing more of these left or right ones just because I think they're a little bit trickier. All right, so it's going to open to the left. All right, Owen, what's my vertex going to be? 3, 0. Careful. That will get you often. Okay, so 3, 0 is our vertex. We've got to do our P here. So we're going to get 1/4 times our A. Technically, you can include the negative here and deal with that like if you're going from a straight formula perspective. Like if you're using those formulas on that second slide without any regard for what this looks like, you can do that. I just ignore the negatives because I'm thinking about whether or not to go left or right based on my picture that I've got. So the negative part tells you which way it opens. When you're doing this, you can just use the a value. So that's going to give you 1 over 1, which is just 1, of course. So our focal length is 1. So to get to our focus over here, we need to go to the left 1 unit. So that is going to be our vertex, and since we're going to the left, I need to subtract 1 from the x coordinate, so I'll get 2, 0. My directrix will be over here. It'll be to the right 1. How is it spelled?
Directrix.
That's a good question. I think it's supposed to be RIX, like I'm writing it, not IRX, like it is printed. What? Let me see if this is a case. All right, so Smart Notebook, its spell checker is not as good as some other spell checkers. So sometimes with a lot of math words, it's not smart enough to spell check the math words right, because you can see like it does have it underlined, but none of the options are directrix, and if I fix it, it still says it's wrong. So that's my justification for why I did it all wrong. It's not necessarily a good one, but sometimes I am smarter than the spell checker on this, because I'm using such fancy words it doesn't even know what I'm saying. But if I spell said fancy words wrong, it's not going to catch it because it's underlining it either way. So it should be RIX. Thank you for catching that. There. So the directrix here, this is vertical. It's going to be x equals. The x coordinate here was 3. We got to go to the right one, so that's going to be 4. And then our axis of symmetry is our last thing. Axis of symmetry is going to be y equals, and our y coordinate is 0. Okay, questions? Yes. Let's finish. Can we wait till we finish these notes? Maybe so, since we are trapped here for 2 hours. All right. So, x and y intercepts here. I'm just going to do one of these. You're not going to have to do a lot of these questions. How do I find an x-intercept? X-intercept, y equals 0. So you don't actually have to put this in any type of form for this. Just go with what you're given. So it's -9 times 0 plus 3 times 0 squared equals 30 plus x. And then, so that's just 0 equals 30 plus x. And you would subtract that 30 there. So we'd have -30 equals x. So -30, 0 would be your x-intercept for this. And then you're going to do something similar for the y-intercept. You're going to do x equals 0. So that's going to be -9y plus 3y squared equals 30 plus 0. So we just got negative 9y plus 3y squared equals 30. How do I solve that? Move everything to one side, factor it if you can. So we're going to have 3y squared minus 9y minus 30 equals 0. So moving everything over there to the left side. We can make our lives a little bit easier if we will divide off by that 3. You could also, I don't know if this one's going to factor. I don't think it is. Yeah, 5 and 2 will work. It will factor. Negative 5, positive 2 equals 0. So we get y equals 5 and y equals negative 2. And so that would be 0, 5, and 0, negative 2. And you will find with parabolas most of the time, you are going to have, if you have one x-intercept, you'll have 2 y-intercepts, right? Because this is going to be one, this particular one opens left or right. If you have one y-intercept, you have 2 x-intercepts most of the time. There is a chance that you have a rare case where it just like comes down and touches the x-axis and goes back up, where you only have one of each there. It is possible not to have x-intercepts at all or y-intercepts at all for these as well. So I think that's probably enough practice with those, though that should be pretty straightforward for you guys. So on Canvas, I'm going to change. On Canvas, you guys are going to do an assignment from that page that's posted there, 13 through 21. It says only graph odds, but what I want you to do is I want you to sketch a graph like I was doing for these problems. For every problem, you do not have to graph them on graph paper, but I want to see like the picture with the points labeled. So it doesn't have to be on graph paper.